Okay, so today is 10.7, and everything starts with memorizing this form, right? So you guys have it on your paper, and it's there already for you, and you need to memorize this form and try to get a understanding of what's going on, what it represents, and all that. I'm going to talk about what the A is, the B, and the D. This form could actually be a little bit more complex, and that will happen if for any of you guys that take advanced math next year. Get a little bit more complex form of this, but if you learn the three aspects on this form, then that'll help you out there. Look, we've been through this before. Y equals mx plus b. We've been through y equals a times the quantity x minus h quantity squared plus k with parabolas. So it's no different here with trig functions. There are things located in certain places that tell you a lot about the function. It's exactly the case with our trig functions. So we need to learn what the A is, what the B is, and what the D is. And once we know those aspects, then we're going to more readily be able to graph the functions and understand what's going on with them. So first off, let's start off with the A value. The absolute value of A is the amplitude. We talked about amplitude a little bit back on Thursday. What's the amplitude? How much the wave rises and falls below the rest position. Some say the zero position, but it depends upon where the wave is located. So that's the concept and that's the idea. So the absolute value of A. Why do I say absolute value? All right, let's suppose the A value is -7. The amplitude is 7. Absolute value of -7 is 7. Let's suppose the A value is 5. The amplitude is 5. How much does it rise or fall above the rest position? 5. And so here we've got an example, and you can see with the color coding, the 2 is the amplitude, right? I'm just going to do amp here. And this is similar to number 6 that you guys did in your homework. 6 had a 4 there. Y equals 4 sine theta was your homework question. This one is y equals 2 sine x. So what I'm going to do is, you've got the pattern here on the right, and I'm going to take this pattern here, and I'm just going to apply an amplitude of 2. Everything is 2 higher. So we've already learned, you don't need to do this, I'm just focusing your thought, right? We already learned the key points, the 0 point, the max point, halfway back to 0, 3/4 to a min, and end up back at 0. So if we just apply the amplitude to those 5 spots, we're in great shape. 2 times 0 is 0, and that first point, you can do this in red on your notes, is a 0. That first point is a 0. Well, our second point is normally 1. 2 times 1 is 2, though, and we're up to a 2 here. Our third point is 0. 2 times 0 is 0, and that thing's still at 0. Our 3/4 point is a -1, and 2 times -1 is -2, and we're down there. So the 3/4 point is down at -2. And then finally, the rest position again at 360, 0 times 2 is 0. And here's the sine wave with an amplitude of 2. So you're just going to try to go through and, again, curve it. It's not supposed to be V-shaped. It's supposed to be a curve. And here is your amplitude of 2. Right? And it doesn't matter where you're at. It's still a 2 value. Doesn't matter whether you're falling below the line 2 or rising above the rest position 2, your amplitude is 2. Now, you can do the exact same thing with an XY chart and graph y equals 2 sine x with an XY chart. But again, the problem there is you have to understand what values to choose. And if you don't choose the correct values, you're not going to necessarily have all the points that draw the sine wave. So what we're trying to learn is the pattern and the key points that will allow you to graph that wave. Amplitudes shouldn't be hard. They're not designed to be that. They're not supposed to be that. All right, what happens if it's negative? What if A is negative? Well, what does that negative in front mean? It means that the wave is reflected, some say mirrored, about the x-axis. Mirrored about the x-axis. All right, so we've got two examples on this one. Y equals negative sine x. First off, the amplitude is the absolute value of negative 1. And be careful, the amplitude is 1, not negative 1. Amplitudes are always positive. So the amplitude of that example is 1, not negative 1. If that would have been a negative 4 in front of the sine x, the amplitude would be 4. That would be a negative 7, the amplitude would be negative 7. That's negative a half in front of the sine x, the amplitude is a half. It's always the absolute value. However, the negative does tell us everything is reflected. All right, so if you look at a reflection in a mirror, things are backwards. I'm trying to think of the situation where sometimes somebody will take a picture and they'll have the picture rotated and not know it, and things are on the opposite side of where they ought to be. I don't know if you've ever done that before, but the picture's reversed. We are mirroring this about the x-axis. So here's the x-axis. So it's your line of reflection, if you want to think of it that way. You guys would have learned that term in geometry, the line of reflection. So we are reflecting everything about that axis. Well, go ahead and take your red. 0 is just 0. Nothing changes there. Because again, here, let me at least do a dotted line here. That line of reflection, a 0 is right on the line. So there's no change. However, when you get to the first quarter mark, instead of being 1 above, we are now 1 below. Because we're reflected about that x-axis. When you get to the halfway mark, you're right on that line of reflection again, so the point's still right on the line. Because there's no change, it's right on that line of reflection. When you get to the three-quarter mark, instead of being below 1, you have to reflect, and now you're above 1. And 360, same scenario again, you're right on the line of reflection, so your point's right there. So how would you graph y equals negative sine x? You would simply go this way. You would reflect the sine wave. That was lousy there. You would reflect the sine wave about the x-axis. Now, if the amplitude was bigger, it would be reflecting with a bigger amplitude. But negative sine x, instead of heading up in the beginning, heads down. It's reflected about the x-axis. So the cosine is the exact same way. So again, we've got a negative cosine x. Your amplitude would be positive 1. Absolute value of negative 1 is 1. Can you draw the reflection of the negative cosine x? Go ahead and draw negative cosine x. Go ahead and draw the pattern right on there. Do it in red, or if you're chicken, do it in pencil. This way you can erase it if you need to. Go ahead and draw the pattern for negative cosine x. So hopefully you said okay. Instead of starting out at a max, we start out at a min. 0 stays 0, mins go to max, 0 stays 0, max goes to min, and you should have drawn it like that, right? It's mirrored about the x-axis. Any questions on either of those two? Aiden? from the pattern, remember the pattern is the base model. So the pattern is a base model with a couple things, Aiden. A one amplitude. So we can change the amplitude, and therefore then the reflection would look different. For example, don't put this in your notes because you'll muddy it. What if it had -2 cosine x? Then this first point is going to be down here at -2. This next point is going to be up here at +2. And when I reflected that one, it would look like this because the amplitude's bigger. Okay? But so it still reflects, but it's never going to be an exact replica of the pattern unless it has an amplitude that is still the same as the pattern and a period that's still the same as the pattern. Okay? And we're going to learn in a minute how to change the period and how to do the vertical shift. Okay? So as long as it's a basic model, it's a direct reflection. But once you understand that, then what hopefully we'll get decent at is knowing how to do it as I just did with a 2 amplitude, a 7 amplitude, whatever. Right? Any other questions at this point? Amplitudes. It's the multiplier of the trig function, right? If you look at the function, it's whatever's being multiplied directly times the trig function is that amplitude. No matter where the trig function is located, that's the amplitude. And that's going to affect how far the wave rises and falls above the rest position. All right, B. What about the B value in that formula? All right, so let me scroll back up. Notice the B is the multiplier of the angle. Remember, X here represents the angle. So, you got to be clear here. This is the angle. So we have BX. That angle instead of X could be theta, right? Real common angle symbol, theta. Could be alpha, real common angle symbol, alpha. So it could be B theta or B alpha or BYs or whatever else. All right, could be. So it's the multiplier of the angle is what the B is. All right. So what does B represent? B equals the number of waves in 360 degrees, or if you want to think radians, 2 pi radians. But note I say for the sine and the cosine. The tangent's its own oddball, right? Danielle asked a question earlier, okay, what about this question? The tangent isn't continuous. And I started off showing her the sine was continuous. Sine's continuous, cosine's continuous. They, normal 360 for a period, number of waves. The tangent is different. So the B represents the number of waves in 360 degrees for a sine or a cosine. All right, we'll get to that in a minute. So how do you find the period? How do you find the length of one wave? And remember, this is the period again is the number of degrees in one full wave. The number of degrees in one full wave. Or the number of radians in one full wave. How many degrees or how many radians do you go before this thing repeats itself? The repetitive nature. And that's what we're talking about with period. So the B value will tell you the number of waves. If you want to know the actual period, how many degrees in one complete wave, if you're doing degrees, divide 360 by B. Number of degrees in a full wave divided by B. If you want to do radians, take 2 pi, because that's how many radians in a full wave, and divide it by B. Right? So it depends on what you're doing. Are you doing degrees? Are you doing radians? In either case, you're going to divide either 360, a complete wave, by the B value, or 2 pi by the B value. All right, let's see if I can try to make all this make sense to you. So using color, obviously you can see that the B equals 1/2, right? Hopefully that's obvious. B is a half in our example here. So here's what I'm saying. This one has 1/2 a wave in 360 degrees. Because the b value is a half. Right? It has 1/2 a wave in 360 degrees. Because the b tells you how many waves in a normal 360 or 2 pi. Now, if I wanted to find the period, did I leave myself enough room? All right, I'm scrunched up here. I'm going to put a little dividing line here. If I want to find the period, then I've got to take my 360 and I've got to divide it by my 1/2. The period's going to tell me how many degrees in a complete wave. What's 360 divided by a half? Just say it if you know it. What is it? Oh, you guys are so scaring me. 360 divided by 2 is 180. How can it be 180 divided by a half? Or you got to invert the half and multiply. It's 720. Oh, brother. All right. Just invert the half and multiply it times the top, right? How do you divide fractions? Invert the second and multiply. So it ends up being 2 times 360, 720. Let's see if these two make sense. If there is a half of a wave in 360 degrees, then wouldn't the full wave take 720 degrees? And it does. And it does. So watch how you would graph this. Okay, I'm going to set up a complete wave. For our example, we start at 0, correct? And for our example, we end at 720. Do you agree? Now, I've already put some stuff down below, right? So here's the wave end, right? One full wave is 720. You always want the halfway mark. So I went halfway, and I put mid, right? You always want the first quarter mark. So I went halfway between the start and the mid, and I put first quarter, right? And you always want your third quarter mark. So I went halfway between mid and the end, and I put third quarter. Because those are the key points. All right, I'm going to graph this in red. So how does the sine wave always start? What's the pattern? The first mark is at 0. Where is the sign at the first quarter for the pattern? No, we're not doing degrees. We're doing now how high or low is the sine value at the first quarter mark of the pattern? 1. So where is it going to be now at our new first quarter? At 1. I'm just going off the pattern. Look, so here's what I'm doing. Don't mark this in your notes because it's just going to muddy things up. Look at the blue pattern right now, right here. Blue pattern. At the first quarter, isn't it at a max of 1? So now for our new one at the first quarter, it has to be at a max at 1. We're stretching this wave out. Okay, the pattern at halfway at the midpoint, what's the value of the pattern? What's the value of the pattern at the midpoint? 0. So what's going to be the value of our new wave at the midpoint? Still going to be 0. Only our midpoint is now at 360. By the way, didn't we just get half of a wave in 360 degrees? Isn't that half of the sine wave? It is. At the 3/4 mark of the pattern, where is the sine? At what value? -1. So where we're going to be at our now new 3/4 mark, we're going to be at -1. Again, you guys got to be looking at the pattern and then applying it now to this situation. And the pattern, where does it end at the end of the wave? Back at 0. Where are we going to end at the end of our wave? Back at 0. And so now you can finish this thing off. And notice how we stretch the wave out. We have a complete wave, but it takes 720 degrees now to complete that total wave. If you don't know how to do this from the pattern and you try to use an XY chart, what happens is you just end up getting a bunch of points usually in here, and you don't know what to do with the wave. You have no idea where to go from there. Look, we need to go all the way to 720. But again, if we know the key points of the pattern, the start, the first quarter mark, the halfway mark, the third quarter mark, and the ending mark, we then just apply it to the new situation. Aiden. And stretch out, yes. And that's where we're heading. But I knew I wouldn't be there yet today. So if you looked at Info Direct, you'd see that you don't have homework yet. We'll finish this up tomorrow and have the homework. Here's what I say on